Hey, what's up, guys? This is Chung here. So it's been a few days. Yeah, I had some back pain after overdoing on the rowing machine. So anyway, so I think this one's today's daily challenge problem, number 927, three equal parts. Um, so this time you're given like an array, which consists of only zero and ones, right? And now this time we need to divide this array into three empty parts such that all of the parts represent the same binary value, right? So basically and and we need to return those two separate index, right? So basically it's I and j, such that so we have array here, right? And we need to divide into three parts, and we need to return I and j. So let's say we have I in here, right, and j's here. So if we have I and j here, so we divide this array into three parts. The first one is this part. The second one is from I plus 1 to j minus 1, right, which is this part, right? And the last one is from j to the end, right? So that's the three parts we want to return here, right? If it's not possible, return is minus minus. Okay, and so for example, this 110 represents to 8 to 6, right? Also, the leading zeros are also allowed, right? Basically, the 0, 1, 1 is equal to 4, so this is okay. Okay. So for example, we have the 10101 and the output is 03, right? So because uh, we we divide it into three parts, right? The first one is 0, which is this part, right? And then the second part is this one here. That's why we have 0 and 3, right? Based on the definition here, right? So and then this one, it's not possible, right? Because I think one of the observations is that the number of ones, right, has to be divided by 3, right? Because in order for us to get like three equal parts, all three parts should have the same number of ones, right? So obviously this one is not, it's 4, right? That's why this is not possible. And this one is 2. This one is possible, right? Obviously, so we can divide into this one and from here and here, right? So that's this is the three parts, because be careful. So because here we cannot divide it at here, because otherwise we'll have 1, 2, and 1, right? That's why we have to divide it in this way. That's why we have 0 and 2. Okay. And oops. So that's all the examples here, and the constraints is like this, almost 10 to the power of 5, right? Obviously, given like this big this constraints scale, we cannot brute force it, which means we have basically we try to find all the possible three divisions, right? That will be like n square, right? Sorry, not n square, n cube, right? That this will definitely TLE, right? So which means given this string constraints here, we cannot even do n square. We have to find like a better one, either on or n log n, right? So for this one, it's possible to have on. And why is that? I think we already on that path, right? So the first one is that we have to so each part, right? So each part, let's say we have three parts here. Each part has to have the same number of ones, right? So that's the first one. And the second part is what? The second observation is that the zeros in between them also has to be the same, right? Because we already know. Let's say we have this one, we have 3 ones, right? Let's see that in total we have 9 ones, but and then the second part, the observations we need to make is that each between each one, right? There has to be the same number of zeros, right? For example, you have 0 here, and 0 here, right? So this part has to be the same, right? 0, 0, and 0, right? Here has to be the same, 0, 0, and 0. If any parts have, let's say if there are like more zeros in between, this is okay, because we can always split the array, in a way that we can include some leading zeros. The only exception is that the part 3, right? So anything that after part 3, basically in part 3, if we have more zeros here, those zero has to be counted in the last part, right? For the part 1 and part 2, if we have more zeros here, it's fine, because leading zero is a lot. That's why we can somehow cut this, move this index around. But for the last one, we have to count everything, uh, all the zeros in the last part. Okay. So what we can do is that okay. So first we know, if we count the total number of ones, we already know that we can have like the index for the first ones in each part, right? So which means, let's say we have p1 pointing to here, right? So basically I'm going to have like 3 pointers. The first one is pointing to the first ones, right? And then P2 pointing to what? P2 pointing to the first one of the second part, and P3 points to the first one of the third part, right? So, and then what can we do? So obviously, as you guys can see, basically since we already know the P3. That's why we already know what's the value for the last part, right? Like I said, we have to count everything after this P3. That's why what we can simply do is that we can simply uh, move these 3 pointers all together, and then we compare the bit value one by one, right? So which means that and as long as there's a case that any values, right, any part any value in each part, it does not equal to each other, then we can simply return -1, right? Only when everything are the same until the P3 reaches the end of the array, and then we know, okay, we have find a split, and what will that split be, right? So let's try to simulate this one. Okay, so in this case we have P1, P2, and P3, right? For example, if we have another zero here, right? So for example, if we have 2 zeros in between, right? Obviously, this one is going to be a false, right? Because it's not equal. That's why, because when we trying to move this P1, P2, and P3, so P1 equals to P2 equals to P3, right? So next one is 0, 0, and 0. That's fine. But the third one, so right, so 1, 1, but this one is 0, right? It should be 1. That's why, for example, in this scenario, we're gonna return like -1, -1, right? So if everything works fine, right? So we have 1, 1, 1, and 0, 1, 0, right? Everything works fine. And at this moment, and we have another 2 zeros in the end. That's why we have to move 2 more zeros, right? And now the P1 is here, right? And then the P2 is pointing to here, right? And then P3 is pointing to here, right? So this one still are still the same, right? And then the next one is that we're gonna move P3. So now P1 is pointing to here, right? And then P2 is pointing to here, right? And then P3 will be basically pointing to the end of the array, right? And that's when we can say, okay, we have find a split, right? Because we have already compared each of the numbers, right? Each of the bit value. So at this moment, so what will that split be, right? So now we have, it's going to be this one, right? So this is the first part, okay? How about the second part? Second part is this one, right? Second part is this part, right? And the third part is what? Is this one? This is the third part, right? Because so here since we can only we have to split this array into three parts, right? That's why the leading zeros are fine, right? But for the first part we cannot include more zeros than it needs, right? Which is three zeros in the end, because the last part we only have like what 1 0 1 0 1 0 1 0 0 0, right? That's when we need to stop. Okay, and so what's going to be the value here? So remember, so the first part is the p1 from 0 to p1 minus 1, right? So this is the first part. That's why what we need to return is that p1 minus 1, and then p2, right? Because p2, right? So the definition of the second index is that from p1 to p2 minus 1, right? That's exactly what we need here. And the last part is p2 to n, right? That's why we just need to return p1 minus 1 and p2, right? So I think that's the basic idea here. And cool. I think we can start coding then, right? So first step is to count the number of ones, right? Count of 1, right? And if ones cannot be divided by 3, right? We simply return, let's define like minus 1 minus 1. Okay, it's going to be the default result, right? So we can simply return the answer, right? And then we have the target, right? So the target will be the ones divided by 3, right? So now we have all the targets, and let's try to populate the pointers, right? The three p1, p2, and p3. It's going to be 0. I'm going to maintain like a count for now, and so for I enumerate of array, right? So how can we find those the starting point of p1, p2, and p3, right? So if num is equal to 1, right? If count is equal to 0, and then p1 is going to be I, right? Else if count equals to target, right? And then p2 equals to I, else if count equals to 2 times target, right? And then p3 equals to I, right? And then don't forget to increase the count by 1, okay? And then we have length of the array here. So now we have the p1, p2, and p3, right? So all we need to do is that we just need to simply try to remove all 3 pointers together and then compare the values for all 3 pointers, right? Until the p3 reach the end, right? So which means that while p3 is less than n, right? But before doing that, we also are gonna have like the p1 smaller than p2 and the p2 smaller than p3, right? I think here, since we'll be moving P1, P2, and P3 all together, I think this part we have to make a copy, right, of P2 and P3, right? So this part is make sure the P1, P2, and P3 will not cross over each other because, for example, if we have 1, 0, 1, 0, let's say 1, 0, 0, 0, 0, right? So P1 starts is here, P2 is here, P3 is here, right? So P1 should never cross over P2. Same thing for P2 and P3, right? P2 should never cross P3, right? That's why let's do a P22 equals to P2. I know the name. Uh, Original. Old P2. How about this one? Old P3. Okay. So basically, we should use old P2 here and old P3 here, right? Um, so we check if the P1 does not equal to P2, right? This or the P1 does not equal to the P3, right? So if any of them are not equal, we simply return the answer, right? Which is -1 and -1, right? Else what? Else we increase P1, P2, and P3. P3, right? +1. Okay. And then in the end, we simply check this, right? We simply return, like I said, P1 -1 dot P2 if P3 is equal to n, right? Else answer. This one. I think the answer seems weird here. Okay, I'll just use this one to represent that. So I think this is better, right? So basically, in the end, we simply check, right? Simply check if the P3 has reached the end, right? If it is, then we return this split. Otherwise, -1. That's, for example, this one, right? Even though everything here works fine, but once this while loop is finished, right? Uh, because it will stop before when the P1 reaches P2 or P2 reaches P3, right? But at this moment, the P3 has not reached the end, right? That's why we cannot find a split because as you guys can see, the part 3 is 1, 0, 0, 0, right? This is it's a pretty big number. That's why we check this one. In the end, only when P3 is equal to n, then we know, okay, we have find a split, and split is P1 -1 and P2, right? And I think that's it, right? So if I run it, okay, so this one accepted. If I run this one, oh, sorry, there's a corner case which is all 0, right? Um, yeah, with all 0, as you guys can see, right? Uh, I'm returning -1 because because P1 equals to P2 equals to P3, right? And okay, I think we can simply do this, right? We can simply check that in at the very beginning, right? Basically, if here, right? Easy. If ones equals to 0, right? So if everything is 0, what does it mean? It means that we can split at any location, right? I think the easiest one is just to split. Basically, I is equal to 0 and j is here, right? That's the. I think we can just return this. Return like 0 and 2, right? Because again, right, so the split is a little bit different. So the first part is from I, and the second part is from I +1 to j -1. That's why the second part, the smallest index for the second part is 2, right? That's why it has to be 2, right? Actually, no, this one can be anything, right? But since the length of the array is could be 3, right? That's why we can use this 0, 2, and this should always work. And I think that's it, right? So now if I run it again, Yeah, so now it passed, right? Um, yeah, as you guys can see, right? So we have what? So this is O of n, right? To count once, and here is what? It's also like O of n, right? So it's also O of n to find the pointers, right? And then the last part is this while loop. Since all the pointers always moving forward, right? So this part is also O of n, right? So in total, this is O of n time complexity, right? And space complexity is O of 1, I believe, right? So we only use a limited number of the variables, right? Ones, the P1, P2, and P3 and target, right? Yeah, I think that's it, right? So for this one, not too difficult. The only thing we have to be um insightful is that we have to realize that the last part. Oh, first is that each part has to have the same number of ones, right? So that's not too hard to get, right? And the second observation is that the last part is the most important part, because starting from this one, starting from the first one of the last part to the end, everything has to be considered. That's why actually we're kind of using the last part, right, to check if we have already found a split or not. And the last thing is that we just simply compare, right, all starting from the first one to the end. We compare the bit one by one, right, to make sure they're all equal to each other. That's how we make sure all three parts are the same, have the same binary value, right? Because to be able to have same binary values, each bit has to be the same, right? Basically, if the value is 6, right, it means that it has to be 110, right? Basically, we have to have 1 1 and 0. It cannot be anything like 1 0 1 or 1 or 1 0 0, right? As long as the one bit are different, then the final result will be different, right? That's why we can compare the values bit by bit, right, to make sure all three parts are the same. Uh, yeah, I think that's it for this problem. I'll just stop here then. Okay, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.